The second case is the case of transition metal and a non-metal. This is similar to the first case where we had a metal and a non-metal. Here we have a transition metal and a non-metal. Transition metals are named in a different way than regular metals. There are two ways to name them, either using the stock system or the IC and the IS system. Now, transition metals, these are the D block. So if you look at the periodic table, this is the D block over here. And these are called the transition metals like cobalt, nickel, copper, zinc, silver. All of those are considered to be transition metals. In addition to lead, tin, and antimony. These are not transition metals, but we're gonna go ahead and treat them as a transition metals. So when you're naming a transition metal, it's not like regular metal. So there is you have to indicate its oxidation state, meaning how many electrons it is losing. At the beginning, we agreed that metals, they lose electrons, right? But with the transition metals, they can lose one electron, they can lose two electrons, or they can lose three electrons, or even four. It depends on the metal itself. Like, for example, if you look at, let's see, if you look at table 5.2, which I posted on eCampus, we're going to use this table a lot to figure out the charges of the transition metals. Like, for example, copper. So if you look at copper, we have two cases of copper. We have copper plus and we have copper 2 plus. Copper 2 plus meaning that it lost two electrons. Copper plus here, it lost one electron. So copper 2 plus is a higher, we say that it is a higher oxidation state. Oxidation means losing electrons, okay? So this one is a higher oxidation state because it's losing two electrons versus here it's losing one electron. So if you're working with a higher oxidation state, the ending is IC. If you're working with a lower oxidation state, then the ending is the OUS. So we call it cuprous. So here, this one's called cuprous versus cupric. Same thing as, let's see if we have iron. If we have iron. So iron 3 plus versus iron 2 plus. So iron 2 plus is a lower oxidation state. So lower oxidation state, you end in OUS. So it's going to be ferrous. Okay. Iron, we call it fer, Fer. So this is ferrous versus ferric. This is how we use the ic in the OUS system in there. When you name transition metals, you never ever use prefixes. The prefixes are for the non-metals, the di, tri, tetra, penta, all of those. We did those for the case when you were using two, or when we were naming two non-metals. We use prefixes. But for transition metals, you can use either the IC or the OUS system. This is actually less favorable to use, but it is used, but not with all the transition metals. The other one that is more favorable to use is the stock system. What is the stock system? The stock system is a system that uses Roman numbers after the transition metal to specify the charge of the transition metal. And this one is more reliable in there. The IC and the OUS system, those they represent higher oxidation state and lower oxidation state. You can use either or, but not every transition metal we name it as an IC or the OUS in IC OUS system. It's just the common ones like ferric, ferrous, cupric, cuprous, stannic, tin. So tin is SN and tin is named stan. So if it is 4 plus, this is a higher oxidation state. It's losing 4 electrons versus 2 electrons. So this is stannic versus a stannous. And other examples are in the table that I showed you. So the stock system in there, what is it? What is it? It shows the charge of the transition metal. And the charge of the transition metal is written as a Roman number and it's written in parentheses. Okay. So how do you know the charge? It's very easy because this is the case of a metal and a non-metal, right? So you already know that the bromine is minus, right? And you have two of them. So this means that copper, to balance the bromine, it needs to be 2 plus. So if it is 2 plus, then its a charge is going to be Roman number 2. So when I name it, I name it as copper. This is its name. And between parentheses, I put the charge of the copper. So this here is the charge of the copper. It's not how many coppers you have. It's the charge of the copper. And then you do have a bromide. It ends in IDE because the nonmetal is just one type of element. Okay. I can also name it as an IC in an OUS system by simply naming it as a cuprous. No, it's actually cupric bromide because this is a higher oxidation state. If you look at the table, Cu2 plus is named cupric. Okay, let's have another example. So Sn is 10. So I'm going to name this as 10. And now I want to figure out the charge of the 10. I know that the chlorine is 1 negative, so this is 4 negative. Then the 10 has to be 4 positive to balance it, so 10 is going to be 4. You guys, if you're working with a metal and the metal is a transition element, or it is one of those elements in here, tin is not a transition, by the way. If it's one of these elements in there, then you have to indicate the charge of this metal. You have to do this because if you don't indicate the charge, we won't know the charge, so the name will be wrong. So you cannot say it's tin chloride. No, it is tin 4 chloride. And if I want to name this as an IC and an OUS system, go to the table, see what's the name of the SN4 plus. This is stannic. And then you put a bromide. Okay. Another example here. This is Fe is iron. So we're gonna name this as iron in the stock system. Now the unit for or the charge for the iron, the Cl is negative. This is 2 minus. So Fe needs to be 2 plus to balance. So that is gonna be iron 2 and the chloride. If I want to name it as an X system, then this is gonna be ferrous chloride. Iron can lose 3 electrons or 2 electrons. Okay, so yeah. Here iron, this is the case of iron losing 3 electrons. So this one is an Fe3 plus and the Cl3 minus. All of those are ionic bonds if you have noticed. Then this one is going to be iron 3 and the chloride. To name this, that's going to be ferric chloride. Okay, moving down, this is CO. CO is cobalt. And then now I have my nonmetal part to be a polyatom, SO3. So I'm going to go up there in the polyatomic table. And SO3, where is it? SO3 is the sulfite. This is 2 negative. It's called sulfite. And it is 2 negative. Then I would know what is the charge of the cobalt, though. Okay, so that is sulfide. So I know that SO3 is 2 negative. So the cobalt has to be 2 positive just to balance it. And the name is going to be cobalt. It's going to be 2. Okay, it's going to be 2. And then it's going to be sulfite. Cobalt can either lose 2 electrons or it can lose 3 electrons. So this one is called cobaltous sulfite. Okay. You do have zinc chloride in there. So zinc chloride, this is zinc. It needs to be 2 plus just to balance the 2 negative. So it's going to be zinc 2 and the chloride. This one has no IC and OUS system naming. And then you have CuCl. This is going to be copper. See, the Cl is negative, so the copper is going to be positive just to balance it. So I know that copper here is going to be 1 and then chloride. So if I want to name this, then it's going to be copperous chloride. Okay, that is going to be copperous chloride. You guys check the spelling. Whenever you want to write copper, it's COPPER. Whenever you want to put the OUS or the ick, then it's going to be CUP. It's cuprous. Okay. So the spelling is going to be different in there. Now, if I have the name, or actually, yeah, if I have the name and I want to go ahead and get the formula in there, guys, don't forget that this 3 is the charge of the chromium. Okay, it's not how many chromiums I have; it's the charge of the chromium, and the chromium is a Cr. So it's telling me here that the chromium is a +3 because I do have a 3 in there. So this is the +3, and then the sulfur in there. I know that sulfur is in a group what? Sulfur is in a group number 6, so it's going to lose 2 electrons in there, right? Now I need to balance the charges. So to balance the charges, I do exactly as I did earlier before. I just cross the charges, crisscross the charges, and the formula is going to be Cr2, and it's going to be S3. Okay, Cr2 and S3. Whenever you are naming any one of those cases, please take a look what type of metal you are working with. If it's a transition metal, or if it is PB, antimony, or lead, then PB, antimony, and what is the other one? Tin, tin. So it is PB, antimony, and tin. Please make sure to put the charge of the metal. Put the charge of the metal. So here the charge, the chromium, I go and I say, okay, the sulfur is going to be 2 minus. This is going to be 6 minus, right? And that 6 minus over here, see the 6 minus, has to be balanced by a 6 minus in there. So I have to multiply this guy by 3. So 3 times 2 is equal to 3 times 2 is equal to 6. So now I know that the charge of the chromium has to be plus 3. This is why I have a 3 in there. Okay, let's have another example. Manganese 2 oxide. I know that manganese is +2 because it told me that it is a +2 over here. And I know that the oxygen is 2 negative. This is it, right? So my formula in here is going to be Mn. This is manganese and it is oxide. Okay. This one is manganese. It's not magnesium. Magnesium is not a transition metal. Magnesium. So if I say magnesium oxide. Magnesium is not a transition metal, so I don't need to put any Roman number charges in there. I know that magnesium is going to be 2 plus, the O is going to be 2 minus, so the formula is going to be MgO. Okay, there's a big difference between magnesium, which is a group number 2. It's a metal. It's an alkali, or it's an alkali earth metal, versus manganese, which is a transition metal. Transition metal, they go with different charges because you have Mn +2, Mn +1. So this is why you have to indicate what is the oxidation state for it. Copper chloride, so it's given that copper is 2 plus and the chlorine is negative, right? So go ahead and crisscross those charges in there, and it's going to be CuCl cupric. So when I say cupric is a higher oxidation state. So you go to the table and you see what does cupric represent. Cupric represents Cu3 plus. Okay, and the chlorine is a negative. So go ahead and crisscross those charges, and the formula is going to be a CuCl3. Cupric chloride is the same thing as copper 3 chloride. Manganese 1 oxide. So it's given me now that the oxidation state of the manganese is +1. And then I know that the oxygen is 2 negative, right? Charges are not balanced. So go ahead and crisscross these charges. And it's going to be Mg to Mg, not Mg, I did the mistake. It's going to be Mn. It's manganese, I'm sorry. So this one is an Mn, not an Mg, okay? So manganese, not magnesium. So it's going to be Mn2 and then O, and this is the formula for it. Nickel is a transition metal, okay? So nickel is Ni, and nickel here is +2. So this is one is going to be +2. And then acetate. So for acetate, I look at where's the table? I look at the table over here. Acetate is a poly atom, and it is somewhere here. So this is the acetate. It's a CH3 CO2 negative. This is the acetate. So we're gonna go ahead and write that down. Okay. So this one is a CH3 CO2 negative. This whole thing is a negative charge, is a negative one. I'm going to put this in parentheses, as I said earlier, because it does contain more than one atom in there, or more than one type of an atom. So it's a polyatom. And then I'm going to go ahead and cross multiply. So I'm going to have nickel and then a CH3CO2 parentheses, you guys, and then this is going to be 2. So the 2 is for every single element in here. So you have 2 carbons, you have 6 hydrogens, you have another 2 carbons in there, so a total is 4 carbons, and then you have 4 oxygens. Okay? Copper cyanide, so this is a lower oxidation state for copper. Copper has 2 oxidation states, +1 and a +2. +1 is cuprous, +2 is cupric. So, and then the cyanide, if you go to the table, the cyanide is somewhere over here. Um, Here you go. So this is the cyanide, and there's a CN negative. It's a CN negative. This is what a cyanide is. So you have a CN and a negative. Okay, so for both of these, plus minus, this is it. So your formula is a CuCN. Okay. Um, the last thing is naming hydrates. So what are hydrates? Hydrates are solids that can absorb moisture from the air. And when they absorb moisture, it's going to be in a form of water. So water molecules will stick to the solid and hydrate it, make it having water molecule in its crystal lattice. So an example of a hydrate is copper 2 chloride dihydrate. So here I'm indicating how many water molecules I have. I have 2 water molecules here. So di means 2 and hydrate is water. So I have 2 water molecules. So I'm going to put a dot and put 2 water molecules in there. So what does that mean? It means that copper 2 chloride is my molecule, okay, is my inorganic molecule. And this molecule has in its lattice 2 water molecules around it, okay? And then I'm going to go ahead and draw the copper 2 chloride. So that is going to be copper. It's going to be +2 in there, and then the chlorine is going to be negative. So if I want to go ahead and draw the formula for it, it's going to be CuCl2 dot 2H2O. Okay, no space. There is no space in here. So we're going to go ahead and put dot 2H2O. Okay, what does that mean? It means that for every one molecule of CuCl2, there are 2 water molecules around it in its crystal lattice. Okay, this is how you name the hydrate. You put a dot and then you put how many water molecules you have. So trihydrate, you put a dot. This is a 3. So this is a 3 water molecules, and then you draw the molecule there. Barium chloride. Barium is a group number 2, you guys. So copper is a transition metal. Barium is a regular metal. Okay. So that is so you have barium, you have chloride. Barium is group number 2, so this one is a Ba2 plus, and then you have the chlorine, which is negative, cross the charges, and the formula is going to be BaCl2 in there. So barium is a regular metal. You do not use any Roman numeral to indicate any oxidation state in there because it's a regular metal. The Roman numerals are just for transition metals. So know what are you working with, okay? Copper 2 sulfate, pentahydrate. So pentahydrate is 5 water molecules. This is 5 water molecules for every 1 molecule of copper 2 sulfate. So we're going to write the copper. Copper is +2, and the sulfate is SO4, and it is -2. So basically, this is it. This is the formula in there. So it's going to be copper sulfate dot 5 H2O. Okay. The last thing is the naming of acids. There are 2 types of acids. there is a binary acid. A binary acid is an acid that contains two elements, a hydrogen and another group. And by the way, these rules in there, you do not have to memorize for the acids. You can go ahead and put them on a piece of paper. And then you have oxo acids. These are acids that have a hydrogen and they are made up of two other groups, and oxygen is one of the groups in there. So for the binary acids, I mean, you do have two elements in there, or two different types of elements, let's say. So HF, these are two different types of elements, HBr. So binary acids, they start with a hydrogen. They have start with a hydrogen. So how do I name them? I name them by starting the name with a hydro, and then I name the non-metal, which is fluor, right? And then end the name in ic acid. So hydro and ic acid are a must for all of them. So the ending of the name is an ic acid. So you have hydrofluoric acid, hydrobromic acid, hydrocyanic acid, hydrosulfuric acid in there. This is how you name acids that start with a hydrogen, and they are made up of two different types uh, of atoms. Okay, in there. The CN, by the way, the CN here is a poly. It's a polyatom. It's named cyanide because it is a CN. It's we're not naming the carbon alone and the nitrogen alone. This is a polyatom, but it is considered to be a binary acid. Now for the oxo acid. Oxo means oxygen. You have oxygen in there. So HCN is not an oxygen or an oxo acid. So oxo acids, they are acids that start with a hydrogen for sure, and they have a lot of elements in it. And one of the elements is oxygen. Like for example, H2SO4. Okay, this has a hydrogen in there. It does have a sulfur. It does have an oxygen. So this is considered to be an oxo acid. So oxo means it does have an oxygen. So whenever I want to name this, I'm going to end the name in ic acid. Okay. It depends on the oxidation state. How much oxygens do I have? Do I have more oxygens or less oxygens? For the acid that has more oxygens, I'm just going to give it the name ic acid. The one that has less oxygens, I'm just going to name it as an is acid, OUS acid. So this is the difference between both of these acids. Sulfuric acid and sulfurous acid. Both of them, they contain H2SO, but this one has four oxygens versus this one has three oxygens in there. Okay, SO3. This is a sulfite ion. So sulfite ions has less oxygen, so we're gonna change the ic into an OUS. So it's gonna be sulfurous acid. This one is a nitric acid. So HNO3 is a nitric acid. If I want to go ahead and name an acid that is HNO2, then that is going to be a nitrous acid. Less oxygens. Phosphoric acid versus phosphorus acid. Okay, less oxygens as well. Now, acids with one more oxygen. So if I add one more oxygen here instead of H2SO4, so in this case, I'm going to use the prefix per. So per means I added one oxygen and additional oxygen. So that one is going to be per, and then the similar name, sulfuric acid. I know that the nitric acid is HNO3, right? So if I add an oxygen, becomes HNO4, so it's going to be per nitric acid. This is per chloric acid. And then acids with one less oxygen. So if I have one less oxygen than the regular acid over here, no, one less oxygen is here actually. It is H2SO2 because SO3 is the sulfurous. So SO2, this is one less oxygen. Then I'm going to use the prefix hypo. So pair means more oxygens. Hypo means less oxygens. So it's going to be hypo. And then, of course, the ending is going to be is acid. So it's going to follow this guy over here. So it's going to be hypo sulfurous acid, hypo nitrous acid, hypochlorous acid in there. Okay. So all of those are considered to be acids. And then we have acids and polyatoms that contain a hydrogen. So here we have an acid that simply starts with a hydrogen in there. The acidic part is the HSO4. The Na is the plus, the HSO4, all of it here is negative charge. So this is your acidic part in here. This is a plus, this is minus in there. So your acidic part there is a counter ion and it starts with a hydrogen. So we're going to give it the name bi. So it's going to name this as a sodium. It's going to be bisulfate because SO4 is a sulfate, right? But if you add the hydrogen, hydrogen is named bi. So this is a bi in there. Bi means that I have a hydrogen next to the SO4. I either name it as a bisulfate or I name it as a hydrogen sulfate. This one over here is going to be a dihydrogen. I cannot use bi anymore. Bi is one hydrogen. But if you have two hydrogens, please use the di. So this is going to be sodium dihydrogen and phosphate.